Good morning. Welcome to the plenary session, which is really in two parts. I'm starting out the day with you and I'll end the day with you. And we're going to spend this morning part talking about the first question, what is early math? And then you're going to get to two breakout sessions and talking to each other at lunchtime. And when we come back in the afternoon, we'll really dig in a little bit more on why does it matter, when you have some more fodder in your head for that. But the very first thing that I would like you to do is to turn and talk to your elbow partner, the person next to you, and just, two people, so everyone gets to answer this question. And answer the question, what is mathematics? Not early mathematics, but simply, what is mathematics? And I want everyone to talk. That's why I just want you in pairs, where one person talks, the other listens, and then flip off. So please start with that. All right, so I don't want to hear what you had to say right now. I could see there was a lot of conversation, and I hope you were talking about this, because I really do want you to think about that. But I want you to do an activity. I'm going to try to give you some fodder for more understanding of what mathematics is. So look at this photo and turn and talk to the person next to you about this question. How could we sort this collection of objects? How could you sort them? Think about that. And can you sort them more than one way? How many ways can you sort them? Okay, again, it's great to hear so much spirited conversation. So raise your hand if you came up with more than one way to sort this collection that you agreed on. Okay, keep your hand up if you came up with more than 2 ways, more than 3 ways, more than 4 ways, more than 5 ways. Wow. All right, here I have a few ways that we thought about this when we were creating these photos. So one way is that we could sort by using a yes-no question. This one was, is it something that I can ingest? Does it contain something I could ingest, yes or no? So how many of you thought about this as a way to sort? So that whatever it was, a clementine, the water bottle, the tea bottle, they all contained something to ingest. Everything else was no. Anyone else think about that? Did anyone think of a different yes-no question, where it was something that was all one thing and everything else was not, even if it was a different question? Did anyone else think about a yes-no question? Me too? Yeah? Okay. So that's, how else could we resort it? Let's think about that. We could sort considering the function of the objects. Okay? And the functions that I came up with here are communicating, it's the left. The pens and the paper and the phone are about communicating. The middle is the ingestibles plus some lip balm, because they're all about the body. And the right are things you use for other objects. Keys open doors, and the cloth cleans glasses and things. So that was, so you would, obviously, people come up with different things. So how many of you, though, came up with some ways you talked about what they get used for? In maybe different groups, but what they get used for. How many people? Me too. Do your little, me too. Hang 10, me too. Okay? People thought about the functions of the objects. But there are still other ways. So we had a yes-no questions. Let's thinking about the functions. You could sort by looking at the shape of the objects. So here I did cylindrical, not exactly perfect geometric cylinders, but cylindrical, rectangular, again, not perfect geometric rectangles, but rectangular, and then roundish, other. They have roundness to them, but they're other. They're not exactly like each other, but they're not like in the other groups. But it's about the shape. How many of you thought about shape? Yeah, me too? I expect some of you came up with some other things in thinking about shape as well. All right. So another way we could resort is to look at the color of the objects. These were reddish-orange. The red and orange go together. Silver, blue, and purple. Now, you might do color in a different way, but that's how I did it when I made these photos. I had the red-orange group because orange has red in it, and I had the silver group, the blue group, and the purple group. So how many other people thought about the color of the objects in a way to sort? Me too. So we had a yes-no question. We thought about the function. We thought about the shape. We thought about the color. Were there other things that people thought about besides that in sorting? And if someone just wants to yell something out nice and loud. So you thought about colors, but you defined them a different way? Okay. Did people think about things that weren't color or shape or function or a yes-no question? Or does... So some people thought about size, tried to categorize about size. Now, when you're categorizing all of these objects, I think some of the animated discussion was both what to make the category, and was some of the animated discussion what goes in which category? Like if you're doing size, and obviously you didn't get to touch them, so it's harder to tell, but where does small end and large begin? And does orange go with red? Maybe if you did color, you needed the red bottle by itself because it was red and the two things with orange by themselves. I mean, so there had to be some conversation about what the rule meant, right? Okay. So I want you to think for a moment about why was what we just did, and this time I really just want you to think for yourself, not share with each other. Just think for yourself for a moment before I do the next thing. Why was what we just did something mathematical? I'm trying to give you some mathematical thought, mathematical juices in your brain flowing. Why was that mathematical? So just think for yourself. If you had to tell somebody, what would you say? But I'm not asking you to say it right this moment. So I'm going to give you another little food for thought about what mathematical thinking is, and hopefully everything works the way I want it to. We're going to go to the earlymath.erickson.edu site to watch a short video of a preschooler. So you see, just so you see, all these little video clips we have, we've edited them to be short and watchable, so sometimes there's context that's useful. You see she's got two versions of this star that are both using 6 of the blue rhombuses to create it. And now the adult is going to ask her, well, could you use some different kinds of blocks? And you see it's a shape frame that she can put down and pick up. So that's the challenge. And I also want to let you know that this sort of video, we call them focus on the child videos, and you're going to see some in some other sessions. And we created these, the Early Math Collaborative, and the adult is working one-on-one with a child, but it's not an official assessment. It's, they're not going to get some score out of it, and we have a plan for it, but we also kind of follow what the child does, because what we wanted to do was get good math thinking to show people. So we didn't need to follow a particular protocol. If the child says or does something interesting that sparked our, then we'll push them to that. So we want to get interesting stuff. And the child's does not know this adult very well. And that adult has no particular goals for the child other than that they have fun and that we hope we capture some good thinking on camera, but they don't want to be sure they have a particular skill or they can check something off on a checklist. We just wanted to have an interesting interaction with the child. So here the adult is asking her about other blocks she could use.
I'm going to see if we can try and use other shapes. Maybe you can start with this one.
Triangle.
You're using triangles.
Triangle can make me show.
You're going to use triangles to make this shape? Let's see.
But it's not going in.
Oh, it's not going to go in. I wonder what you're going to do to make it fit. Maybe after you put all of these in, you'll figure out what to put in there. Now what are you going to put in there?
A flower.
But there's a lot of space in there. Can you think of another shape that could go in there? Oh, look at the hexagon. It fit. Let's lift it up and see your star. Let me move this out of the way. Look at that star. Do you think you can try to do another using other shapes?
Yes.
Okay, let's see. Try and use other shapes. Maybe you can start using this one.
Okay, I'm going to. Hey, I can't.
Oh, you found a triangle in there. Oh my goodness, look at how you're doing this. You're really thinking ahead of what shape goes next.
Oh, a shape. I'm going to make a shape.
You are making a shape. You're really looking for the other triangle.
Oh, a diamond.
A diamond. A rhombus. Is it going to fit in there?
Yes.
Let's look at your star. Oops. Oh my goodness, look at all those. You used different shapes for this one and for this one, and these two you used the same ones.
So, you did a sorting activity. You've watched this child do a shape composition activity. I want you to think then about this question: what is mathematics? You did an activity that got you thinking. You watched a child doing an activity in which I hope you could see there was thinking going on. So you have some new ideas now about how you would answer this question if you had to, write the new dictionary definition of mathematics. What would it be? So again, turn and talk to the person next to you about this question again and think about, do you have some new ideas? Thank you. I don't know how many of you might be thinking, Chris Maxwell told me these people were experts in mathematics, and why are they asking us to do all this work and define mathematics for them? Aren't they supposed to be here to tell us what math is? And yes, we have a lot of opinions about what math is, but part of what we think math is a logical way of thinking that allows for increasing precision. Mathematics is a logical way of thinking that allows for increasing precision. And you can't understand math if you don't do math. Doing math does not mean taking a course in mathematics necessarily. You might do math in a good math course, we hope so. And doing math does not mean having a career like certified public accountant or engineer or computer programmer, though again, if you did have such a career, you would presumably be doing a lot of mathematics. Doing mathematics means thinking logically about the world around us. And I see people taking notes. I just want to, that's great if that helps you think and learn and process. All these things will be posted. So if you're copying it just to get our exact language, don't worry about that. If you're making notes, because that's part of how you learn, keep doing it. So mathematics is thinking logically. When you were sorting objects, you had to have a logic. What kind of rule are we going to sort by? That's part of the logic. And then another part of the logic is, what do we mean by that rule? Defining it more carefully. That's logical thinking. That's what math is all about. Math is not about knowing right answers, because just having memorized some right answers doesn't help you do anything with it. And I'm taking some time belaboring this point because it's key to thinking about the role that people who work with children from birth to 8 play in people as adults feeling competent and confident in the math that they need to do in their lives. Because everybody needs to do math in their lives. Everybody doesn't need to do arithmetic, a lot of arithmetic in their life. Everybody doesn't need to do a lot of, calculus or analytical geometry or, higher algebra in their life. Some people do, but a lot of people don't. But we all need to do math in the sense that we need to think logically. And we need to think logically about numbers, but we also need to think logically about other rules, and that mathematical thinking allows us to do that. And what you do with children when they're babies and toddlers and 2-year-olds and preschoolers and kindergartners and first and second and third graders, how we lay the foundations for that mathematical thinking is crucial to their being able, as older students, but also as adult citizens of the world, to be able to think logically about the world, okay? Because we use math to make sense of the world. We use logic to make sense of the world. Very early on, we have to use logic to make sense of the world. This idea of sorting is something you have to do because as human beings who live in adapt to so many different environments, we can't be hardwired for all the instincts and behaviors we need. And part of how you have to learn about new behaviors involves sorting things out. If every object you saw in the world, if every experience you had in the world, if every place you went had to be its own separate thing in your mind, you would quickly run out of space. But when you organize things, a baby's organizing things into what we suck and what we don't suck, and what's comfortable and what's uncomfortable. If we don't sort our experiences and the objects in the world, we would be overwhelmed because we aren't hardwired with instincts, and that's how we can adapt to so many things in the world and invent so many things and do so many jobs. So we're using mathematics to make sense of our world. And in fact, even when people are learning language, babies are learning language, many studies have shown that they are actually somehow, not because they learned it in school, but they are using statistics in a way. They're gathering data on the language around them. All babies, you may all remember this, but if you've forgotten from your child development classes, all babies start to babble in a language-like way at a very similar age and in a very similar way. But after several weeks of this sort of babbling, you'll notice a change in it, and it sounds more like the language that is being spoken around the child. And profoundly deaf children do less and less babbling at this point. So at first, it seems to be this just instinct to make these noises, to use the vocal cords. But it's shaped by what they hear. And there's these studies that show you can manipulate things. They're really working on the statistics of what happens more often somehow in their brain. They're using the logic of that to figure out how language works. So we use language to make sense of the world. We also use, we use mathematics, we do use language. We also use mathematics to make sense of the world. And we use mathematics to solve problems. We use logic to try to figure out how to solve problems. And they don't just have to be numeric problems. So here's our one-slide definition of mathematics. That it's a logical way of thinking that allows for increasing precision, and that we use math to make sense of the world, and we use math to solve problems. So that's what math is. I want to take a moment right now to tell you a little bit more about who we are. And you will notice that this is coming several minutes, quite a few minutes, into this presentation. And that's because of something about our belief about math, that you need to jump into math and be a mathematician and get your mind towards that and not think about too many logistical details up front. So I put this slide in the middle. So we are from the Erikson Institute, and we're the Early Math Collaborative. And the Early Math Collaborative celebrated 10 years of existence last year. We've been around for 10 years. And we started out working with preschool and kindergarten teachers, all from CPS schools, doing both professional development, the kind of stuff we're doing today, though usually in a series, and also coaching these teachers and providing support for coaches who worked for CPS and their understanding of math and how to coach around math. We've expanded our work up through 5th grade in some settings, though our biggest focus is still on the lower years, but we've been working with the CPS Department of Math in doing work with their 3rd to 5th grade teachers as well as their preschool through 2nd grade teachers. And we've expanded our work down to 0 to 3 years. We've been doing work mostly so far with Educare Chicago and other centers that the Ounce of Prevention in Chicago supports, and focusing on helping those teachers think about what does it mean if math is a way of thinking. We know children are born thinking. What are we doing at that point that supports their mathematical thinking? And our mission statement as the Early Math Collaborative is that we are transforming the understanding, teaching, and learning of foundational mathematics from the ground up. That's what we're about. And that's what we hope we will do some of with you today. And then Erikson Institute, a little bit more about what Erikson Institute is. We are, as Chris Maxwell said, a graduate school of child development located in Chicago. This building has not been around for 50 years, as you can tell. Erikson Institute celebrated 50 years in 2016. It was founded in 1966, at first with this focus on helping give child development knowledge to Head Start teachers. You know, Head Start was just starting, and it was really started with that focus of helping Head Start teachers be prepared the way they needed to be prepared to do that work. And it still has a graduate school that trains teachers and social workers and other people who work with young children, but it also has a lot of projects like ours. We work with teachers, but we are not part of the graduate school. When you're with the Early Math Collaborative, you're not doing graduate school work. And there are other projects like that, some working around literacy, around technology. There are also some programs that work with children and families directly. So there are a bunch of service and engagement programs. But all of it is knowledge in the service of children and knowledge of child development in its many forms in the service of children. And one of the things we like to say around Erickson is, it depends. That this knowledge helps you make choices, because we cannot give you a recipe to do any of these things exactly right. I mean, there are some things around caring for and working with young children that there can be a kind of step-by-step recipe for, like there are certain steps in, you know, changing a diaper or washing hands that you could, oh, let's think through doing it this way, we'll cover our bases. But most of what you do has to be grounded in knowledge we have about how children are and how learning happens. But exactly what you need to do, well, it depends. It depends on the particular children in front of you right now. It depends on the situation that you're in. So it depends. We're going to give you a lot of good ideas about mathematics today. We are not going to give you a recipe for exactly what to do when you're back with your group of children, or if you're someone who works with, you know, the teachers, what to do exactly with your teachers. We're going to give you some information, and then we're counting on you to figure out exactly what to do with it, which, of course, everybody at Ericsson believes it depends, and we in the Early Math Collaborative really embrace that, because what are you doing? You're using your mathematical thinking. You're thinking about the logic of the situation and your understanding to figure out what to do, because it depends. So, back again to thinking a little bit more about early math and what it is we do with early math. And one of the things that we at the Early Math Collaborative do is focus on the whole teacher. Many of you, I hope, have a strong grounding in child development already, and I assume you have heard the phrase that we need to focus on the whole child. Give me a me too if you've heard that phrase. We need to focus on the whole child. That means we need to think about their physical development and their physical state at the moment. We need to think about their emotional development and their social development and their cognitive development. And we need to think about, you know, what time of day it is and what time of year it is and what happened at home. That it depends. We need to focus on all of who the child is. There isn't just one thing. There's no perfect curriculum, no perfect set of materials. Those things matter, they're tools, but we have to focus on the whole child. And we believe that we also need to focus on the whole teacher. We need to think about adults. What is their knowledge? And help build that. Because I know, particularly around math, that there are many people who spend their lives working with young children who in their earlier lives did not have a very pleasant relationship with math. Math as it came to you in school might have been difficult or just done inappropriately and not a way that made sense to you, and you reject math as that weird school thing that I'm not any good at, right? So there are attitudes about math that relate to the knowledge. So perhaps because of those attitudes, you don't really dig in and think about math in the classroom other than I'm going to get a book that has some good math activities and I'm going to buy some good math materials and I'm going to check that off on my list. But I myself am not going to think really hard about the math because the whole idea of math scares me. So we have to address the knowledge of what math is, which is what you're going to do in your breakout sessions in different areas. What is the math? Not all of it. We're just going to give you a little taste because all of what math is going to take you years to figure out. But we'll give you a taste today, get you started. But we also want to change your attitudes about math. It seemed like people were kind of having fun when they were talking about the sorting and that they appreciated the fun that that child was having in doing the puzzles a different way, that positive mindset towards solving this problem. And again, there's also then the practice. So how do we do this? There isn't an exact recipe, but there's certainly strategies that are effective that we can talk about, sample activities. Well, you can try it like this, but again, there's not one recipe. So it'd be like, well, here's how one teacher did it. How would you do a similar thing, but what practice considerations do you have to think about for your setting in your classroom? And I see many of you who have been reading this about that it would be hard to trust gardening advice from someone whose own garden was an overgrown weed patch. I suspect it's also hard for children to believe that learning math is exciting and worthwhile unless the adults in their lives actually value and enjoy learning math themselves. We added in the word math. She just said it about learning. But, I mean, I think it's true. Learning it, you know, if we're not excited about it, they're not going to be excited about it. And they know the difference between real excitement and fake excitement. So we got to dig in. And one of the ways that we do dig in is to think about precursor concepts and big ideas. So a precursor is something that comes before and prepares or signals something. Examples are, you know, red sky at night, sailors delight. Red sky at morning, sailors take warning. That's a saying of many years that has some validity in our understanding something is signaling something else. Or when leaves turn red and fall down, we know winter is coming, if we live in a climate where that happens. So in mathematics, a precursor concept is a concept that underlies or prepares the ground for a big idea. It's not really the math itself, it's that mathematical way of thinking, but it's not yet the math you would recognize as math. So this is what children from birth to 3 are developing, these precursor concepts. So it's this idea that, you know, it starts, and it's weird that picture was bigger when I was looking on it last night at my screen. Somehow it keeps shrinking down on me. But they're bulldozing at first, you know, that's 0 to 4, you're beginning it, thinking about it, and then from, you know, the next year, you're laying out where the foundation might be, and then finally in your 3rd year you're really actually putting down some of the walls and getting ready to build the building. All right, and those of you who come to the Birth to 3 session, we'll talk more about this. And then that lays the groundwork for what we call the big ideas of early mathematics, and we actually have written a book about it, Big Ideas of Early Mathematics. Whoops, where did that go? Big Ideas of Early Mathematics. What teachers of young children need to know, that is really focused on the math that children 3 to 6 are building on that foundation of precursor mathematical concepts. And they are these really important ideas that they lay the foundation for the future of math, and You can explore them at a young age, but you also continue to explore them for years to come. An example of a big idea of early math is that we, excuse me, we use attributes to sort collections into sets. How many of you used that idea this morning? You didn't probably say those words, but you used that, right? You thought about the attributes of the objects. You sorted them into sets. And that big idea builds on a precursor concept just of attribute, that there is attribute. Like I was saying, that babies think about what you can suck and what you can't, or what's comfortable and what's prickly. So you start with this very general idea of attribute, and it gets refined, and then in the preschool and kindergarten years, you can be thinking about, oh, I can choose attributes and I can sort by them. So that's the idea of a big idea that goes along. And these big ideas are things that are for teachers to focus and clarify their goals for children's learning. It helps you understand what is going on in math activities. Where's the math? Because if you just take an activity from a math activity book, even if you do exactly what they say, you put out the exact materials, you say what they say, if you haven't thought about why it's math, it's not necessarily going to be mathematical learning for the children. And because there's a lot of overlap, we've often seen people doing a math activity that really just becomes an arts and crafts activity, because the teacher isn't thinking about how it could be math and not having the right conversations or asking appropriate questions or noticing what the children are doing. So to be big, an idea has to be mathematically central and coherent. It has to be consistent with children's thinking, and it has to be generative of future learning. So you can see how all those things are true about that idea that we can use attributes to sort collections into sets. And I want to stress again that these precursor mathematical concepts and big ideas are tools for adults to understand foundational math and to notice and plan for children's learning. I am concerned sometimes when we share big ideas and precursor concepts that people then want to go back and teach them as vocabulary to children, because we sadly have occasionally seen that happen. So take that precursor concept of attribute and the big idea that we use attributes to sort collections into sets. I don't want you to make sure that every 2-year-old who's talking in your group knows how to say attribute, attribute. Color is an attribute. Shape is an attribute. Texture is an attribute. There are many 2-year-olds who would happily do that for you. Okay? And it's great. They know how to talk. They're learning a new word. But that itself is not mathematical thinking. And a child who maybe doesn't do that isn't so verbal or doesn't like to parrot what you say, but who is busily actually sorting things and putting things together that go together and doing it again different ways or noticing different things, that child is using that precursor concept of attribute. The same thing with the older children. We don't want them to parrot. We can use attributes to sort collections into sets, and we can sort the same collection in different ways. You want them to actually be doing it and to say, oh, I put these together because they're round, and these other ones over here, they're the not round ones. And then another child comes up and says, oh, I like green ones. And so they pull green. They say, I'm going to make a green group. And the other child says, well, you can't have my round green ones. And we talk about how that might overlap. That's the mathematical thinking, not the parroting back the idea. And we have so often, as a culture, and particularly as an educational culture, really overvalued language. I mean, language is valuable, but we see it as a marker, so that if a child says attribute clearly or says out this sentence, we use attributes to sort collections into sets, or can very quickly go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We think they know about sorting and counting. But we don't know if they do. They're just saying some words. And it is often the case that children, especially the ones who are good at saying words, memorize words and parrot them back to the adults around them, but can't give you evidence that they know what to do with it. And this can happen later and later. One of my favorite studies of recent years about, that motivates me thinking about why early math is so important is a study they did with 8th graders, and they were actually testing them about all sorts of knowledge. But one of the things they did was they asked them to come up with a story problem for which the mathematical expression 2 times 3 equals 6 could be a solution, part of the solution to the problem. And I forget the exact percentage, but way too many, half or maybe more than half, could not do that. They were not failing in math. They had learned rules, they could pass math tests, but they couldn't think back to why would you want to know that 2 times 3 equals 6? What is it good for? And that's really scary, right? And that's the same with the kids. We get them to parrot back the words or respond to flashcards, but can they use it? Can they make sense of the world with these ideas and solve problems? We don't know just from the parroting back. So we need to give situations where they can use it, and that's way more valuable use of their time. So these tools for you as adults to understand what the math is. So it goes back again to this idea of the whole teacher development, that precursor mathematical concepts and big ideas, they deepen teachers' knowledge of foundational mathematics. If you spend time thinking about it, you think, oh, that's what math is. Math isn't, you know, that last class I had to pass in college to finally be done. It's these logical ideas. Oh, and that's why doing this kind of work with children helps them develop math, because here's the mathematical idea. And then an expanded knowledge hopefully helps teachers feel better prepared and more confident that they really can do math themselves and do it with kids and recognize it and make it work for them. And then that knowledge and that changed attitude will impact practice. So all of those things together build that whole teacher and build both the understanding and the attitude as well as change practice. Because as I said, we can't just give you a recipe or a perfect activity book or a perfect curriculum and say, you know, we've got it. There are better curricula and worse curricula in terms of what the math underneath it is, but if you don't know the math, that's not going to help even if you have the very best one. And another point about this is these precursor mathematical concepts and big ideas of math, they exist outside of those specific activities, curricula, and standards. Hopefully, once you've thought about them, you can recognize them in specific activities, curricula, and standards you have, but they exist separately. They're about what the math is, not about selling a particular product or doing things in a particular order. And they are fairly easy to remember. They're not a laundry list of skills to check off. And again, if you do have some things with skills to check off, hopefully once you've begun to think about the math, you can map those back to, oh, I see why these are in the math list. Not because I want to get every kid to parrot back, because if they can do this on their own, it shows me they understand something mathematically. And they help you mathematize play and other things in the classroom and not just think math is for my math activities. And we think that they put the focus where it belongs, on the thinking and understanding of early mathematics. So Chris had passed things off to me earlier than we had originally planned. So I have time for questions if people want questions. And I actually also, something that I will get in the slides for Saturday, because I forgot because it wasn't on the slide. When I was back at Ericsson, I wanted to tell you, I don't know if some of you saw these cards. So while you're thinking about your question, so I'll say that first thing. If you have a question, think about it. And then when I'm done saying this, we can take questions. We have these cards. They were at the registration table, and they're advertising 2 summer institutes that will be happening at Ericsson this summer. And they're 2 separate events, but they're similar in that they're each 3.5 days of in-depth learning at Ericsson in Chicago. And the first one is something we've done for 3 years now. This will be the 4th year of what we call MEME, which stands for Meaning Making in Early Mathematics Education. And it is really focused on the math that 3 to 6-year-old children are doing. And teachers, but also coaches and administrators are welcome to come. And you don't have to be in the classroom necessarily in a preschool or kindergarten classroom, but that's kind of where our focus audience is. But you know, people who work with 2-year-olds or perhaps people who work with 1st graders could also be interested. But we're really focusing on early math for 3.5 days. And you spend the mornings, everyone's learning about early math together, and then in the afternoons, I'm not going to go into all the detail. You can go and find out more online, but you get to choose. There's 5 choices, and you choose 2 out of the 5, and you dig into something else a bit in the afternoon. And then the next week is a new summer institute at Ericsson called the Big Ideas in Early Learning. And for that one, you're choosing one of 4 tracks. One of them is math, and this one is going to focus a little bit more on the primary math, going to be more like K2. So if you really want to think about preschool math, you probably want to go to the other one. But then there's another track that focuses on literacy, preschool through 3rd grade. Another track that focuses on technology integration in early childhood, preschool through 3rd grade. And a 4th track that focuses on social emotional learning in early childhood, preschool through 3rd grade. So pick up one of these if you're interested. You can sign up to get more information. Registration is not live, but it will be soon. And there are not lots of spots, so if you really want to do it soon.
Thank you, Lisa. Let's give Lisa a big hand.